Welcome to the lesson on the volume of three-dimensional figures. When we think about volume, we imagine those figures and we think about volume being the amount of space that a solid, any of those three-dimensional figures, takes up. So we think, to help us better understand it, we imagine the amount of water that can fit in the pool as being that pool's volume. Recall when we discussed area being the amount of space that was enclosed by a two-dimensional figure. So this rectangle had length and had width, and we wanted to know its area. We wanted to know how many little squares, 1 unit squares, could fit inside this rectangle. For volume, instead of using squares, we use cubes. So I imagine I have a box, a rectangular prism with lengths 10, 3, and 6, and I think about how many little cubes will fit inside. Now I know I can fit 6 cubes up, 3 cubes one way, and then 10 cubes another way. So how many cubes can I get to fit inside of this box with those particular measurements? So I will take the length that I have, the width that I have, and the height that I have of the box and multiply all three. Length times width times height. So in this case, I will do 10 times 3 times 6 and get 180. And I will have 180 cubic inches. Or I can also describe it as 180 inches cubed, and any unit really can be applied to volume as well. Now, even though length times width times height works for this, let's think about the idea of base and how it will work for all prisms. These three prisms all have a different base. This prism has a rectangular base and a height that goes up to meet another one. Even though a cylinder is not a prism, it still has a circular base that has a height to go meet another circular base. This triangular prism has a triangular base with its height to meet another triangular base. So we derive the formula and we think in order to find the total space that a prism takes up, I can find the area of its base, whatever that shape might be, and multiply it by a height, which is the distance between those two bases. Now let's apply this with an example. Let's think about having a triangular prism with all the following measurements. So I know triangular prism will have the formula base times height. Well, I gotta think, my base here is a triangle, so that's going to require me to use 1/2 base times height. Now, even though I'm using base and height again, I'm thinking just about the triangle base here. So 1/2 times 4, the base of the triangle, and 7, the height of the triangular base. So the base of the triangle will end up being 14, 1/2 times 4 times 7, and then I bring down the height of the figure, the distance between those two bases, to get 12. And 14 times 12 will give me 168 cubic units. Now, as I think about pyramids and their volume, it's important to look at the comparison between a cylinder and a cone. Now, note, this cylinder and this cone can have the exact same size, shape, base, but a cone will not take up the same kind of volume. So I still think of base times height, but instead with a cone or other actual pyramids, that base times height will have a 1/3 in front of it. Let's practice with these three prisms and find their volume. In the first example, I have a cylinder, so I will use the formula for base times height. I'll think that the base here is a circle, so I have to use pi r squared. So pi, input 3 for the radius, squared, and that will give me 9 pi. Now I can take that 9 pi and multiply it by the height of 6 and get 54 pi. Now I can leave my answer in terms of pi and say 54 pi, or multiply it out and get an answer of 169.56. With the second figure, I have a rectangular pyramid. So now I have to apply the pyramid formula for volume and 1/3 base times height, and think that my base rectangle is going to have an area of length times width. So I'll input 9 as the length and 3 as the width. 3 times 9 will give me 27. I take 1/3 of 27 and I get 9. And then I'll bring down the height of the figure itself, which is 6. Take 9 times 6 and I'll get 54 cubic units. With the third example, I have a rectangular prism, So I again use the formula base times height. With this rectangular base, I'll use length times width to find its area. So 7 times 2, which gives me 14. I'll bring down the height of the actual figure, which will be 15. And then I compute 14 times 15, which gives me 210 cubic units. The connection for volume of three-dimensional figures is very critical when thinking about capacity, comparisons by price, and then overall buildings and how much buildings can hold.